In this video, we are going to learn how to use some features of Solidplant. We are going to start with the project initial setup. Solidplant can import the data list from the PID provided in the tool Tag Manager. Let's see how Solidplant retrieves the data from the PID by clicking the command Tag Manager on the Solidplant Project Manager pane. The dialog box Tag Manager pops up, and then we press the button Import Tag. We select the PID Excel file that was exported from the PID editor and open just to take a look at how it is organized the information into the spreadsheet. So we press the open button, we select the component type and map to the list from the Excel spreadsheet. We press OK. We click again on Import Tag command, we open it and we map the equipment list to the Excel worksheet. Press OK, check the information, press OK again. And now we go to the valve list. We click on the Import Tag command, select the PID file, open it, map, press OK, and we save it. On the right side, the document list has been updated with all the information we have just inserted. Now we change a little bit our point of view. And then we go to the configuration manager and select a proper configuration in order to work in a clean area. The project configuration system. Solidplant has centralized all of his settings with the tool project property divided in 4 groups: general, piping, specification, model setup, and component color. And then we press OK in order to save our change. So we wait a little bit. And now we get into the 3D modeling. Solidplant provides a lot of tools for speeding up our structure design. We are going to start creating a 3D grid, assign members and columns, use some of the platform models coming with Solidplant, and make a catalyst report. So first of all, we select the configuration, and then we zoom in a little bit, and we edit the subassembly structure from the Feature Manager. We choose the structure ribbon and then click on a Structure 3D Grid button. Automatically on the left side we see the 3D Grid pane. We mark the point of destination, press Get Selected command from the left pane, and then our grid is positioned, and then we set the parameters. 5400, and for the height 4000. And now we have our 3D grid. We click on OK, and now we edit the structure assembly, and also we edit the part. And from the structure toolbar we click on the Insert Structure Member command. On the left side we choose the standard, the type of the shape, and the size of the column. And then the sketch lines where we want to insert the columns. Then we press on OK. Pressing again the structure ribbon, we use now the future Draw Structure Member. We are on 3D Grid sketch mode and we draw the route of our bins. We exit from the sketch mode, and in the new window we select the standard, the type of the shape, and the size finally. In the Feature Manager we highlight the structural member and edit in order to change the direction of the members. So we scroll down and change to the 90 degrees and locate the profile. Now we are going to add some platform models to the plan. So we exit, we edit it again, we select the grid frame 2, and on the upper side we press on the stair command. Automatically we are on 3D sketch mode, and then we sketch a line where the stairs starts. We dimension the width of the model, move a little bit, and then we exit. In the stairs window we will set the parameters. We select 90 degrees left, 2 platforms and 100 degrees right, and for the 8, 4000. We apply, and our stair is automatically being created. We move a little bit, we exit, and we edit again the structure and the grid frame. And now we press on the button leather. And now we sketch a line, again, same concept as before, with dimension 800. And then we exit from the sketch mode. In the new window, we move a little bit just to see the changes. We set the parameter and we apply. We close and we can see our leather. Edit again the structure, select the grid frame, and then we select the handrail command. Same philosophy. We draw the roads of the handrail. Another one here. And then we exit the sketch mode and write the parameter 900 to the height of the handrail. Apply and close. Finally, we are going to add a floor plate. In the Feature Manager, we edit, selecting the part on where we want to put our model, and press the button floor plate, and after we draw a rectangle on it. From this point to the other side. And then we exit from the sketch mode. And on the left side, we set the parameters 20 and flip the cut direction. We click on OK. And we can see that in less than 10 minutes we have a fully equipped structure. We save it. And now I'm going to show you how to make the cut list report of the structure. From the Feature Manager, we select the model in which we want to generate the cut list and open it. We can see our structure, and updating the cut list in the Feature Manager, we will be able to create the report, selecting from the toolbar structure the button Assign Member. In the new window, we check all the detailed information of the model, like the mass properties, and then the cut list of the structure. We have the possibility to rename the section, changing the tag referred to the different size of the members. Once we finish, we apply and see the report created with all the cut items tagged and more detailed information of the parts. We click on the Export to Excel button, save the document under the name Part List, and then save it. We can see the report created in Excel with all the information on it. Now we close our model, and now we get into the equipment section. On the 3D model design, we are going to create an equipment with the libraries that are provided by Solidplant. Also, we are going to learn how to import a model from either SolidWorks or any other 3D CAD software and convert it into Solidplant, as well as define and also load the equipment. First of all, we select the configuration we want to use, and then on the Feature Manager, we edit the subassembly equipment. For a better performance of our design, we can hide the piping and structure subassemblies. So we select both of them and click on Hide Component. In this area, we are going to add a pump, creating a new equipment using the libraries that are coming with this version of Solidplant. So we click on the Create Equipment command, and we take a look to all the components that are available, such as cyclones, exchangers, pumps, tanks, vessels. We select the pump, and on the right side we press the Tag tab, In here we map with the tag to the pump from the information is ready into the project database that were inserted previously from the PID. Automatically the equipment has the information added and the new equipment is already created. We can customize the parameters of the pump. In I, we can change it to 900, we apply, and that's it. We close, and on the right side in the document list we refresh and update the information. So we press on the refresh button and we can see that the pump tag is blue. We mark the destination point, highlight the tag, and then press on button insert component to model. Now the pump is in the model project. We select it and press the button move equipment. From the left side on the move equipment pane we select the move point of the pump and then the destination point. We apply and now we want to rotate it 180 degrees. So we select the spin axis and then the angle. We apply and it's positioned our pump. Now in this area we're going to insert a vessel. So we press again the create equipment button and then select from the library the horizontal vessel and assign a tag manually. And then we click on create. We wait a little bit. And automatically the dialog box of the horizontal vessel pops up and the model is created. We are going to customize, changing the right head of the equipment. We can see the changes and we select semi-ellipsoidal from the drag menu. And then we apply. Next step is to add a nozzle on the body of the vessel. So we click on the create nozzle button. On the left side, we press on the arrow button in order to generate the tag automatically. Select the specification list, the size, and the type. And then we click the new nozzle button. And now we are going to locate it into the body of the vessel. We select the radian, and then the surface reference where the nozzle is going to be located. And now we select the angle, the distance along the model, and then the height. We apply, and that's it. We close and save it. We refresh the document list and scroll down to the vessel tag. We select the sketch center line, the tag in blue, and the insert component to model button. And now we have the vessel located. Now we want to convert an existing model that was created previously in SolidWorks. First step, we create a new assembly. We browse the part equipment, the feed water pump. We open it and insert it. And now we change the point of view, select view points, zoom in, and then click convert equipment. Assign the tag, and then we apply, click on OK. We can see the name is changed. Click on create nozzle, press arrow button for the tag, select the specification list, the size, and then check on the user nozzle and new nozzle button. Now we select the position, zoom in into the nozzle and click on the circle. Automatically the point of the nozzle is being created. We close, we save, we refresh a little bit on the document list tree, and then mark the blue tag and press insert component. We have all our equipment inserted into the model project in just a little short time. In the Feature Manager, we show the subassemblies and we save our project. Let's see now how to generate the piping specifications by using the application Spec Creator. We are able to create the custom specs. We can also use the branch editor where the pipe designer can see and define the fitting status on a chart table, and finally the catalog editor in which we can add a new special item. In the toolbar Solidplant, we'll click on the Spec Creator command and the new application appears. We start pressing on the new specs button on upper left corner, a dialog box pops up, and from here we select the spec units and press OK. And now we save our specification list with the name SP02. We save, and now we choose the catalog from a wide range of selection that is provided by Solidplant. We select ANSI ASME, press OK. From the new table window, we select the pipe and we start inserting the items. 1/2 inch to 1.5, the schedule 80, the pipe, and the material. We preview and we see all the information coming from the catalog. We can change the description name if we want. So, pipe with a schedule of 80, seamlessly, and the material. And then we refresh and we can see that the description column is being changed. We have the possibility to add our own codes. So we can change it, for instance, to 111 in the first row, in the second one 222, and so on. So we click on preview and we add a new row. So from 2 inches to 10, 40, the schedule and the pipe, and also the material. We preview and we see all the information that is going to be loaded into the project database. We preview and we click on add new table. We select fitting, we click on OK, and we insert the values. 1/2 inch to 1.5, the rating 3000, the elbow 90 degrees. We preview and we add a new row from 2 to 10, 40 for the schedule, and then another elbow 90 degrees. We preview and that's it. And we have also the possibility to duplicate the rows and just change the class name in order to speed up our performance. So we preview, check the information, and that's it. And now add a new table. In this case, the flanges. Same concept as before. We insert the values, 300 for the rating, press face, and the type of the flange. We preview, and that's it. Add a new table, fasteners. We click on OK, insert the values, 1/2 inches to 10, 300 for the rating, and for the facing, rest face. We select the gasket, we preview, and we can see that there is 2 types of a standard in the catalog. So we duplicate it, we change it to bold, we preview, and now we add a new table. The valve. We insert the values, rating 300, rest face, and the valve. In this case, valve gate. Preview, check the information, and now we're going to use the branch editor. with all the information we inserted before in the specification list, is now to be shown into the chart table. Also, we have the possibility to customize and add new connections, like stub in. And now we start with the catalog editor, in which we can add a new special item. So first of all, we open and select the catalog we want to use. In this case, we're going to select crane. We open it, and then we select the table, flange. And then we click on build filter, and we are going to have a selection of one special item. So we select the class name, the facing, rest face, the main size, 8, and finally the rating, 300. We save the filter, we type the name, and then we click on OK. The filter has been saved, we apply, and then we have the item selected. So we're going to use as a model this item in order to generate a new item with a special length. So first of all, we can create our own catalog, in this case Solidplant. And then we go to the column component length in order to change the value. 120, and then it's being created, and we save it. And now we get into the 3D pipe routing design using different methods. The first concept is to route a pipe manually and assign the tag from the tag list. And secondly is to generate a pipe routing semi-automatically with a smart fitting. And now, on the right side, we select the Solidplant pipe routing pane. We zoom in a little bit and click on the new model line command. We assign a tag, and automatically all the information is filled, and we can customize if we want. We apply and click on OK. We select Snap to Center on the right side, and on the toolbar routing on the upper left corner we press on the manual route command. Automatically we are in 3D sketch mode, and we can start to design a pipeline. It doesn't matter the definition of the pipe, later on we can set the dimension parametrically. Another line here, and then along X axis button and snap into the center point. Then automatically the model pipe is created with all the components needed. Now, using the Smart Fitting tool of Solidplant, we are going to extend our pipe so that we draw a line starting from the elbow and design another route. Another line here and another one. Snap to center and along XX, and then to the center of the nozzle. And then Solidplant change the 90 degrees elbow to a T in order to adjust the new configuration of the pipe. We exit from the edit mode, and we are going to use the future auto route in order to speed up our design. So we click on new pipe model button, assign the tag, and we select a new color for our pipe and change it to red. Apply and press OK. And from the routing ribbon we click on auto route button, and then we select the start point on this T and to the nozzle of the vessel. We manipulate the route a little bit and press OK when we finish. And now Solidplant is generating the 3D model. But we don't care if it's crossing the equipment. Yet it's not fully defined, so we can change the pipeline position. So one is generated, we can see that it's crossing the vessel, so we can change it and we change the position. We reveal a little bit the elbow, and now in this section of the pipe we're going to use the elevation move pipe command from the routing ribbon. So we select the sketch line, we press the command, select the sketch line again, the target reference, and then set the value for the gap. We apply and click on OK. Now we're going to insert a pipe support, so we click on pipe support button, and from the pipe support manager on the left we choose the type of support and then the surface of the section in order to locate our component, and then the reference face. Automatically the system recognizes the diameter and the length of the support. We can move it and place the support wherever is convenient. We rotate the view and use the filter change size. But first of all, I am going to show a resume of what we can do in 3D routing design. We can manipulate and modify our pipe routing. Solidplant provides functionalities for speeding up our project, such as the little route, elevation move pipe, offset pipe, and so on. We can also add components to the pipe routing and use some more features of Solidplant like change size, etc. So we select the line of the pipe section, press the command change size, and from the dialog box we add the value from the track menu to 150 mm. Automatically the system introduces the two reducers needed for this new diameter. In here we are going to insert a valve gate. So we select the component toolbar, click on the sketch line and press the valve button. We wait a little bit, and from the new window we assign the tag to the valve, the point reference, and press OK. And from the specification list we highlight the valve gate item and click on create button, and the valve will be generated. We wait a little bit, and then we have the valve generated. Now we are going to assign the length of this section. So we select the routing ribbon, we click on the sketch line, and then on the command assign length. And from the dialog box we type 150 mm and press OK. And now we can see that it's been adjusted. So this part of the section will have 150 mm from the flange to the reducer. And now we exit from the sketch mode because we want to manipulate the manifold direction. So we click on it and then on rotate component, and then we set the angle from the dialog box and rotate as many times as needed. So we click on the button again and it's rotating again. And now we are going to use the future jog route, adding to this section of the pipe a loop. We click on the sketch line and then on the jog route button, and then get back to the sketch line. We automatically move and put the route of the loop, and then when it's located, the jog will be created. We wait a little bit, and then the model is created with the other components. So we assign a length in this section, so we select the sketch line and press again to the corresponding command. 300 mm. We click on OK, and that's it. And now we want to make sure that the length is being adjusted correctly. So in this section we go to evaluate it. So we go to the toolbar and select the measure button, and then check that the value is 300 mm, as we can see. Finally, we're going to use the split pipe functionality. So first of all, we go to the pipeline that we want to divide in sections. So in this long section, we're going to use the feature of Solidplant split pipe. We select in the upper side the routing ribbon, select the line, and then click on the split pipe command. On the dialog box, we press on OK for 6000 millimeters as the cutting condition. Automatically, the pipe is split in sections with the value we set it. The system calculates how many pieces is necessary to be cut. So we exit. And then for the last part of the demo, we are going to learn how to create general arrangement drawings, how to create the bill of materials automatically, and generate the piping isometric drawing with isogen alias that is bundled in Solidplant. So we save our project, and then we go to the Solidplant toolbar drawing. So we select it, and then we click on New Drawing button. We select the template we want to use, and now we are ready to generate the GA drawing using the SolidWorks features. We wait a little bit in order to have our document open. And when it's been created, we select the view of our model and drag it to the plane. Now we zoom into the work area. And we go to the sketch ribbon and press the command Smart Dimension. And we add some dimensions. And now another one. And finally, the last dimension. Now with Solidplant, we can select, for example, the section of a pipe. So we select this one, and then press of the button of pipe for the elevation referred to the soil. Then click on another one, and click on line number. We have the detailed information of the pipe. We can change the direction of the node if we want to, so we do it. And now we zoom out and use the functionality of Solidplant bill of material. We zoom out a little bit more, and then we click on the command bill of material in the drawing toolbar. We see a new window where we can customize the list of materials either by line number or by type of components. We can export to Excel if we want, but in this case we close and we add it to the drawing. And now we get back to the project model, and we have a look to the line 006 in order to generate the piping isometric drawing. So we have a look, we check it, and then we go to the drawing toolbar and select the Gen PCF button and select the pipeline and the drawing style and click on Generate. Automatically, the isogen drawing is being created with all the detailed information for the fabrication of the pipe. And this is the standard of the piping industry with isogen. So we get back to the model again and select another pipeline and generate another isometric drawing. And once it's created, we can check the technical information in the isogen drawing in order to check how it is organized information into the document. And we just finished with 3D modeling. We can see that Solidplant uses all the capabilities of SolidWorks for a full performance on plant design. And now with SolidWorks, we are able to save our project on e-drawing format. So we open it, and we can send the model, for example, to a client, and the receiver can open with the free e-drawing software and have a walkthrough to the plan. He can rotate it. In fact, we can manipulate the whole plan. We zoom in a little bit here. We can move. And also we have the possibility to measure all the parts of the project. So the client have the possibility to check all the parts. We can zoom in a little bit here and make a measure between those sections. And also we can make or visualize videos. And select another one.